Okay, so this is 2022 paper 2 question 4. The first part here I'm not going to do because this is just your learning of proofs from trigonometry. So the link is in the trigonometry section of your OneNote. So just you can go back and watch those proofs anytime. So I'm going to head on to the next one. So this is the tan of 15 is equal to this. Now, or write it in this form. So tan of 15 is obviously not in your special angles table, but of course on page 14, we have all the different variations, different ways we can write formulas. So the minute I hear 15, now I know you guys wouldn't be maybe as used to it, but when I hear 15, I'm thinking 45 and 30. So instead of writing the tan of 15, I'm actually going to use this formula. So I'm just going to write it out first. So just copying it out from my log tables. So how did I know to choose this? Well, first of all, I narrowed it down to any of the tan ones. So on page 14, there's a tan A plus B. Now, I couldn't think of anything that would plus to make 15. That would be in the special angles table. The special angles table being the one on page 13 are, 30, 45, 60. So I didn't obviously go for that one. And then I saw the tan of A minus B. And of course, as I said, in my head, 40 minus 35 would give 15. Now there's other ones, like there's tan 2A, that's the double angle. But again, there's no special angle when doubled makes 15. So if the number is quite small, it's probably this formula basically. So I am going to use 45 minus 30. Now, when I do that, I replace any of my A's with 45 and I replace my B's with 30. So I'm doing that in both parts, 45 and 30. Okay. Now, when I look at my special angles table now on page 13, I can see the tan of 45 is 1. Minus the tan of 30 is 1 over root 3, all over 1 plus tan of 45 again is 1, and the tan of 30 is 1 over root 3. So we just need to tidy up, and then I suppose we hope that we get it in this format here that they're asking for. So this obviously is the tan of 15 because 45 minus 30 is 15. So now I'm just going to tidy up the right-hand side. So it might be easier to rewrite it just using your division symbol so that there's not too much going on at the same time. So if my common denominator is root 3, this is technically a 1. So root 3 on top minus, and this guy has the root 3 already. So that's just minus 1. Here again, my common denominator is root 3. The first guy doesn't have root 3 already, so he needs it. So 1 times root 3 is root 3. The second guy has the root 3 already, so it's just plus 1. So I have root 3 minus 1 over root 3. I change division to multiply and invert what follows. That's just rule of fractions you've done since primary school. When dividing fractions, you change to multiply and invert what follows. So I end up with root 3 minus 1, root 3 plus 1. And is that what we're asked for in the question? Yes, it is. So I've presented it in the correct format. Part B, let's have a look. The triangle ABC is shown in the diagram below. AC is equal to BC. Okay, so straight away, I know this is an isosceles triangle. So whatever this angle is, this one is going to be the same. Before I go any further, I can immediately see, well, every triangle adds to 180. The top angle is 45. So that leaves me with 135. And then all I'm going to do then is divide into 2 because in an isosceles triangle, they are equal. So we know straight away that that's 67.5 degrees and that's 67.5 degrees. Okay, so what else do we know? The angle's 45, we've done that, and we know the length from A to B is 10. Now, I don't know, it might be worth our while simplifying that down. So 10 root, I'm just copying it into my calculator, minus root 2. Now, this is coming out to be 7.65366686. I'm leaving in a good few decimal places because I don't want it to affect my accuracy. So the question is find the length of AC. So our actual goal is to find where the pink highlighter is. Now, the minute I'm looking for length of side or angle, I ask myself, is it right angled or not? This is not a right angle triangle, so it has to be the sine rule or the cosine rule. What I normally do is I start by hoping it's the sine rule, and then if that doesn't work, I revert back to cosine. So let's try the sine rule. So the first thing we do if we're in an exam is we copy down the formula because we obviously want to get our maximum marks. So I'm going to write in my formula just to make sure that the examiner does indeed give me the marks for any sort of filling in I do regarding the sine rule. Now, the sine rule, however, we only ever use it in two parts. And normally I say, okay, what we do is we pick a side and we divide by the sine of the angle opposite. So if I pick the side 7.6536686, I'll divide by the sine of the angle opposite, which is 45, and then pick any other side. Now, I'll pick this side and call it x. And I'm going to divide by the sine of the angle opposite, which is 67.5 degrees. So I'm good to go ahead with the sine rule. There doesn't seem to be any issues there around using the sine rule. So now I can cross multiply 7.6536686 multiplied by the sine of 67.5 degrees. And that's equal to the sine of 45 times x. Now, that's my cross multiplying done, but I need to get x on its own. So everything on the left-hand side is now going to be divided by the sine of 45. And this then is just calculator work, so nothing too difficult here. 7.6536686 multiplied by the sine of 67.5. And then I'm dividing that by the sine of 45. So that's just calculator work. Now I end up getting 9.9999. So essentially that is, of course, 10. You know, if you had every single decimal place up here, then of course you would get it on the button. But I pretty much did get it on the button, like considering the level of nines there. And that one's done.